Assalamu alaikum. This is chemistry 11th, and today's topic is structure of atom. Now, before going to the going through this uh, through this through the structure of atom, I would just first of all give you a recap of Dalton's atomic theory, as I have already told you that Dalton, who put forth his famous atomic theory, which is known after his name, that is Dalton's atomic theory in 1808. The various postulates of his theory tell you. First, one of the postulates that is atom matter is made up of extremely small particles called atoms. Now, the second postulate of his theory is that atoms are the same element or identical in all respects. That is, they have got same size, same shape, same mass, and same properties. Similarly, according to him, the atoms of different elements, they differ. They differ in all respects. That is, their size, their shape, and their mass, and their chemical properties. Now, as well as physical properties. Uh, Another postulate of his theory is that atoms combine when atoms combine together to form molecules or to form compounds. And he said that when atoms of same element or different different elements combine together to form molecules or to form compounds, they do so in a simple whole number ratio. One more postulate of his theory is that atom can be neither created nor destroyed. Although his theory suffered various these drawbacks, that is, he could not explain the that why in why the atoms of the same element have got a different masses in case of isotopes. And similarly, he could not explain, although his theory although it could explain the laws of chemical combination based on this mass or atomic mass, but he could not explain the combination of atoms based on volumes, for example, Gay-Lussac's law. And similarly, another drawback of his theory is that he could not account for the nature of the binding forces between atoms or molecules to account for three states of matter. And so these are the few defects of his theory. Then coming towards our to, today to our this present topic, which is structure of atom. Now before now it was before going through the structure of atom, it was the researches carried out by J.J. Thomson and Goldstein. They established the presence of electrons and protons in an atom. So, although their presence was already established by these two men, Goldstein and J.J. Thomson, now the question was to know the position of these particles in the atom. Now it was Thomson, J.J. Thomson in 1898, who put forth his model of atom, which is called as Thomson's model of atom, to account for the position of these particles, that is electrons and protons in the atom. Now, according to this Thomson, he said that atom has got a spherical shape. It is in the form of a sphere, and the sphere has this sphere has got a radius of about 1 angstrom, that is 10 raised to power minus 8 centimeters of radius. Now the protons, and these protons, which are positively charged particles, these are spread over the whole sphere. That means the whole sphere, that is the whole sphere, according to this Thomson, is positively charged. Now as far as electrons are concerned, he said these electrons, they are embedded in these positive charges, that is in these positively charged particles, that is protons. They are embedded in these positive charges, just like these resins in pudding. So these electrons, they are embedded in these positive charges, very much like the reasons in pudding. So this model of atom is therefore also called as plum pudding model of atom. Although this model did not have any this experimental evidence. So this model of atom, Thomson's model of atom, could not. It was discarded. Then, to know the exact position of these subatomic particles, that is electrons and these protons, it was then Lord Rutherford in 1911. He carried out his famous scattering experiment. He carried out his famous scattering experiment to know the position of these particles. Now, what he did, he got alpha particles. As we know that alpha particles, they have got 2 units of positive charge, and they have got mass 4 times greater than that of hydrogen atom. So, or we can say alpha particle is simply a helium. It is simply a helium, helium atom. Now what he did, he got a radioactive element and he put it in a lead block. Now this radioactive element which he put in this lead block, it emitted a radioactive rays, that is these alpha rays. Now this this lead block, it was in front of this lead block, there was a narrow slit. Now these alpha particles which were emitted by this radioactive element, that is lead, they were allowed to pass through this narrow slit in order to get a narrow beam of these alpha particles. Now these alpha particles, they were made to strike against a thin foil of a heavy metal, for example gold, and its thickness was about 4 into 10 to the minus 5 centimeters. Now these alpha particles, when they were made to strike against this thin foil of gold, they got scattered in different directions, and these scattered alpha particles, they were made to strike on a circular screen which was coated with zinc sulfide. Now different observations which Rutherford got from this experiment, he found that most of the alpha particles coming out from this lead block, after passing through this slit, they and falling on this gold foil, most of these alpha particles, about 99% of alpha particles, they passed through undeflected. There was no deflection. Now some of the alpha particles, they suffered minor deflections. That means they were deflected at minor angles, and very very few, that means 1 out of 20,000 particles, they were deflected at large angles, or even they retracted their paths. Now, from these observations, he found that after these scattered alpha particles, they produced flashes of light on this circular zinc sulfide screen, and these flashes of light, they were called as scintillations. Now and from these scintillations, he found how this scattering of these alpha particles took place after falling on this gold foil. Now, what he concluded from this experiment, although Rutherford, he took a thin, we know that he took a thin foil of gold, and he according to him, he said that this foil, it consists of a layer of atoms, and according, he was of the opinion that there is hardly any space between the atoms, between these atoms in a layer through which these alpha particles could pass. Now, as he found that most of about 99% of the alpha particles, they passed through this atom undeviated, or that there was no deflection. He found that most of the space in the atom, it is empty, or it is vacant, and this is called the extra nuclear part of the atom, in which electrons are present, because these, according to him, these electrons, they offer least hindrance to these alpha particles. Now, as he concluded that some of the alpha particles, they suffered minor deflections from this observation. He found that there is some positively charged center in the center of the atom. That is why these alpha particles suffered minor deviations, because alpha particles being positively charged, when they come close to this positively charged center, they got deflected at minor angles. Now, very few, as I've already told you, that about 1 out of 20,000 alpha particles, they were deflected at large angles, or even they retracted their path. So from this, he concluded that this positively charged body, which is in the center, it is very dense, as these alpha particles, they as they passed head on with this positive, they came on head on with these positively charged center. They could not pass through it, rather they retracted their path. So this positively charged center, according to Rutherford, it was very dense. That is why these alpha particles could not penetrate, or they could not pass through it. So from these observations, he gave his model of atom, which is called as Rutherford's model of atom. This is all for today, and inshallah tomorrow I will proceed ahead. Thank you very much.